Okay, so this is the sample assessment paper of P1 for this new specification. So let's solve this. We have around the total mark is 75. We have 10 questions. Okay, so number one is easy. Number one, for this one we just have this equation. You need to differentiate for part A, you need to integrate for part B. That's it. So for differentiation, you know that power will be here, 4 into 3, 12, 3 minus 1, and for this it will be like x to the power minus 2, right? So x to the power minus 2 minus 1 by minus 1. Then you just simplify this, x to the power minus 3, so that's the last line. For integration, we know that we just have to add the power. We just have to add 1 with the power, so integrating this will give us 3 plus 1, 4 by 4, and minus 2 plus 1 by minus 2 plus 1. Along with this thing, we need to write c, so plus 5 by x plus c. Next we have number 2. We need to find the value for a, so you just need to simplify this thing, or what you can do, since we have a root, we can take the square. No, we do not need to do that. We just need to find the value of a. We have 3 to the power something, and this is 3 to the power half, basically 3 to the power half. When you subject a, this will be divided, so 3 to the power minus 1.5 divided by 3 to the power 0.5 as in half. So this will be like minus 1.5 minus 0.5. So that's 3 to the power minus 2, so 1 by 9. You need to simplify this, so 2 cube, x to the power this one. Then you just simplify it, 4 into 8, 2. You just deduct the powers. X to the power minus half, we get minus half, so that's why I just shifted it at the denominator level. P1, P2 is way too easy, like compared to pure math, it is much easier. This is just simultaneous equation. You subject x or y. It's better to subject y, since in that case you just need to replace in this one position. If you subject x, we need to replace in 2 positions, so that's lengthy. So from equation 1, you subject y and substitute it here and solve this simultaneous equation. We have this straight line, and this is a tangent to this equation. So for any straight line, it's mx plus c. So gradient of x, coefficient of x is your gradient, so our gradient is 4. And this line is a tangent to the curve, and we know that dy by dx is basically gradient of tangent. So if we just differentiate it, we get dy by dx, and which is gradient of the tangent, and this is the tangent. This line is the tangent, it's already mentioned. So dy by dx should be equals to this 4. So we get the value for x, but basically we need c. So what we can do, we can just substitute x in this one to get the value of y. So 2, 8, 3, so 9, most probably 9, yeah. Sorry, minus 3. So minus 1, minus 3. This is a coordinate, so you just replace this in this line to get the value of c. So you replace y and x to get the value for c. Next we have to sketch them. We need to sketch this on the same straight line. It's a straight line and this curve, so you just solve at x-axis y0, at y-axis x0. Wait, let me just bring the calculator. So for this straight line at x is y0, x is minus 2. So for y-axis x is 0, y is plus 2. So that's the line. And for this one, 3 and minus 2. So minus 2 and 1, 2, 3. And it's a happy face. So we had to sketch both of them, and then you need to shade this region as in less than this line. So this is the line y equals x plus 2, right? So less than means we are talking about below the line, and for this curve it's greater than, so above the curve. So basically this is the shaded region. For part C, you need to find the set of values of x. For that you need the cutting points. So one of the cutting point is 2, we do not know this one. So for this shaded region, x has to be within this limit. Suppose x is 5, for example x is 5, in that case your answer is this. But so for that you need to solve the simultaneous equation to get this cutting point. So you just equate them and solve. For the time being, I'm just taking the answer from the mark scheme. Wait. So P1 sample paper. So I'm solving number 5. So that cutting point will be, if you just equate and solve this, the cutting point will be 4 and minus 2. So that point will be 4. So like I said, the shaded region is within this limit. So this is the range of values of x. Next we have this graph. We need to sketch f of 2x. It means the x coordinate has to be half. So 0 into half 0, 6 into half 3. So this will be 3. This 3 will be 1.5. As in, if you just draw on a separate diagram, this should look like this. As in, it will take less space. So instead of 6, this is at 3. Because we know that if it's 2f of x into 2, as in 2 into y, we multiply 2. But for x, it's always the opposite. If we have 2x, we need to divide by 2. So this is 1.5 minus 1. The y coordinate is unchanged. You just need to divide the x coordinates by 2. For this one, x plus something, suppose x plus 2, in that case the graph will shift 2 units leftward. But x plus p, so suppose p is 1, in that case it will be at the left side, right? So 0 will shift p unit left side, this 3 will shift, but then again if p is 4, this will be towards the left side of this y-axis, but p is actually less than 3. So let's assume p is 2. In that case, since it's less than 3, it means suppose 2.5 or something. So the main idea is the minimum point will not cross the y-axis. It will still stay at the right side of y-axis. So you just shift the graph, but the minimum point will still be at the right side of y-axis. So 6 will be 6 minus p, this will be minus p, this will be 3 minus p, as in you need to deduct the this value, because whatever they give you for x, you just need to do the opposite thing. We need to mention the x-axis cutting point and minimum and maximum point. So minimum point and cutting point of x square. Even though it intersects here, but we cannot find that one because we do not have the equation to solve for at y-axis x0 or something. So you just mention the x-axis cutting point and the minimum maximum as mentioned in the question. Well, this is easy. We have suppose we have equation y. When you differentiate it, you get dy by dx, but if you need to go back, you need to integrate. Similarly, if you have f of x, if you differentiate, you get f prime x, but if you integrate, you get the opposite. So we already have f prime, so you just integrate that to get f of x. Okay, so you integrate that, you'll get an equation here plus c. Then f of x basically means it's y, right? And the equation is in terms of x. So we have this cutting point here, so you replace y 25, you replace the x here by 4, solve the equation to get the value for c. Once you get the value for c, you need to write the equation again including the value of c. Suppose c is 5, you need to write c plus 5. So let me just show this one. As you can see, we just need to integrate this one. Then we have a plus c. You replace x and y in this equation, you will get the value for c, which is 53. So you write the equation again including the value of c. Line L2 passes through origin, so 0 0 is my x1 y1 perpendicular to L1. So this is L1. If you subject y, you get the gradient. So that's the gradient for L1, but L2 is perpendicular to this one. So you need to use m1 into m2 equals to minus 1. So m1 is this. You solve this, you get m2, which is 2 by 3. So you know the gradient, you know the cutting point 0 0, as in the point through which L2 passes. Find the equation of L2. So x1 y1 is 0 and gradient is 2 by 3. So basically it will be 2 by 3x. Yeah, 2 by 3x. Then we need to find the triangle OBC. Okay, so this is the triangle we are talking about. The thing is, we have L1, we have L2. So if you this is equation of L1 and this is equation of L2. You just equate this two, solve this two simultaneous equation to get the coordinate of C. So solving this will give us the x coordinate and y coordinate, 4 and 6. 4 and 6, and B is the cutting point at y-axis. So line L1 at y-axis x is 0 will give us 26 by 3. Okay, so we can imagine this as, since it's 4, it means this distance is 4, this height is 6, so this is actually 4. So if you draw the triangle like this, half into base into height, this height is the y coordinate of B, which is 26 by 3. This one is 4, so half into base into height should give you the area. So that's 52 by 3. 52 by 3. And if you do not get this idea of taking half into base into height, that we have a 90 degree here because it's the x coordinate, it's the horizontal line, right? In that case, you can also go for since we know the coordinates of all the 3 points, you can go with this modulus formula: x1, x2, x3, you repeat x1, y1, y2, y3, you repeat y1, then you just multiply them in one bracket. That modulus formula of area, but that's way too lengthy. I guess this one is easier. Equation of normal. So at first we need to differentiate this. So 20 is 0, we get minus 4 like this. You replace x equals to 2, x coordinate is 2, so you get the gradient here. Then you cannot take this gradient because we are talking about the normal, so that's why you need to because dy by dx gives the gradient for tangent. Since we are talking about normal, you need to find dy, change this gradient. You substitute m1 and solve to get m2. Okay, so and it passes through point A. X coordinate of point A is 2, so you replace 2 here to get the y coordinate. So let me just take the answer from this, number 9. So you find the gradient and substitute x equals to 2, the gradient will be half. Then you convert that using m1, m2, that will give us minus 2. And when you substitute the value for x, you will get the point 2, 3. So 2, 3 and this one, so you can use y minus y1, gradient x minus x1 to get this line. Then the normal meets the curve again. So the normal, equation of the normal and the equation of the curve, you just equate them and solve to find the intersecting point. Intersecting point between the normal and the curve. The curve, equation of the curve was given, equation of normal is what we just calculated. At first we have 3 sides. Since we have 3 sides, we can just use the cosine rule. And you need to use the calculator in radian mode, so that will give us the value for alpha in radian. Area of the major sector. So if we just complete this circle, this is the minor sector. So we need to find the area for the major sector, as in this one. Okay, so it's alpha is 2.22. You need to find this angle, right? So instead of using 360, you need to use 2 pi minus alpha. So, and radius of the circle is actually 4. This is 4, this is 4. 6 is actually the entire length up to y, but the circle is here, right? So this portion is 4. The total length was 6, so this wy is actually 2. So 2 plus 4, 6. So you need the major area, so half r squared theta. Radius is 4 and theta is this one. We need to find the area of this logo, so we just calculated the major sector, right? We just calculated the major sector. So to find the total area, you just need to find the area of this triangle and then add them. So area of this sector that we calculated in part B plus half AB sine theta, 4, 6 sine theta. Perimeter of the logo, so basically okay, so if we need the perimeter of this shape, this is 9, it's already given. The perimeter is basically the length of the boundaries, right? So this is 9, this is actually 2. 6 minus 4 gives us 2. So this part is the arc length, which is r theta. R is 4 and theta is 4 theta is this one, 4.046. So you just add this arc length plus 2 plus 9, that will give us the perimeter. So yeah, that's the end of P1 sample assessment paper.